I'm Camille from BSCE 1E of Nueva University of Science and Technology, and this is Physics for Engineers 1. And in this chapter, we're going to talk about energy. So, for the first topic, we have here the work. Work can be defined in different definitions. Like, it can be the job that people always do, but in physics, it is something that is being done when a force is applied, which causes an object to move, which causes an object to change positions. That's why it has a formula of work is equivalent to force times distance. So let's move forward to our sample problem. How much work is done in raising a 2-kilogram book from the ground to a height of 1.8 meters? So let's say this is our book, which is lying on the ground, and then we need to lift the book by 1.8 meters. So this is 1.8 meters. That is our height, or that is the distance that we are talking about. And this book has a mass of 2 kilograms. So the forces that acts on this book is the weight, and then of course there's a normal force that is pushing towards that direction. So this force that is pushing upward that will make our book be lifted to 1.8 meters is the one that we are looking for. So in order to solve for the work. So in drawing our free body diagram, we have here the object, and there's our weight here, and then this is our force, or the normal force. And in solving for the normal force first, we need to use the second law of motion, which is acceleration equals net force over mass. So we have net force equivalent to acceleration times mass. And since we have no acceleration here, our acceleration is equivalent to 0. This is already equivalent to 0. That means our net force is also equivalent to 0. But here we have forces of the normal force minus the weight. And since this is equivalent to 0, we have normal force to be equivalent to the weight. And we all know that weight is also weight can be determined by multiplying mass times gravity. So therefore, our normal force will also be computed using that method. So now we can find for the work. Since we have our values here, we have a mass and we have the distance. So first we have a mass of 2 kilograms and then a distance of 1.8 meters. So we have here work is equivalent to FD. So our F here is this, mass times gravity times distance. So we have a mass of 2 kilograms and then the gravity is 9.81 meters per second squared, and then our distance is 1.8 meters. So our total work will be equivalent to 35.316 joules. There. So the total work done in lifting a book up to 1.8 meters is equivalent to 35.316 joules. So this is the end of this video. Thank you so much for watching.